want to like bring it up there because I don't know who's all going to be in the aircraft right now. So
shipping about 1 week early from what the original plans were. The testing in Denver has gone very well. Might as well make the plans to get it down to Florida and give ourselves a little more time at the Cape.
Down there at the Cape, it's a really neat dynamic. You're down there to do one thing, is to get this vehicle ready to go. It's a smaller team. Everyone works very closely together. It's a very strong team dynamic when we get down to the Cape. It's a really neat thing to experience.
I'm relieved that we're at this point. We've taken this spacecraft apart and put it back together 3 times up until now, and we really didn't start putting it together into this configuration until just about 2 weeks ago. So we put the last science instrument on, I want to say around April 10th, possibly a little bit after that.
After an uneventful and sometimes sleepy flight, Phoenix arrives in Florida on the same runway that the space shuttle uses. This will be its last conventional landing. The lander is carefully, gingerly, and slowly transported to yet another clean room. This will be its last stop until the instrument-rattling forces of the launch, nearly 3 months away.
Not seeing the vehicle for over 3 weeks, it looks extremely good. I'm very, very happy that it's here. I'm happy that my crew's here, and the vehicle looks outstanding, just perfect.
It's here at the Kennedy Space Center where the puzzle pieces come together and the science portion meets the delivery portion of the mission. Final mating of the rocket and capsule and delivery to the launch pad must await final testing of the lander.
What's next is we will be taking the heat shield off of it, and we'll be lifting off the shipping base and going over to the spin table to do a dry spin and to find the CG and the balance of the spacecraft.
In preparation for their summer on Mars, every instrument on board and the assembled lander itself have already gone through rigorous testing, including what's called shake and bake. They are encased in a vacuum chamber to simulate the harsh Martian environment, and then shaken vigorously to replicate the forces of launch and landing. The instruments are designed to last for the entire 90 days of the mission, before winter imprisons the lander in thick carbon dioxide ice. Marty, however, has a much shorter lifespan.
The descent camera is designed to take images as we are descending towards the surface to give us a broad overview of the landing site and also to give us higher resolution views than we could see from orbit. The camera was designed to work very well for 2 minutes or 3 minutes, and that was its entire job.
Not the taking of the pictures, but the storing of those images has created a critical flaw. During the multitude of tests back in May at Lockheed Martin, a major communications problem was discovered. The news is just coming to light.
We were originally limited to about 20 images, which we would have taken right after parachute descent started, all the way then to powered descent and then eventually to the surface. However, a recently discovered problem on the spacecraft has limited us to a single image that we will hope to take somewhere around 300 meters above the surface. There's a computer card inside the spacecraft that my camera connects to, and that card has a problem when it's reading data from the camera at a high rate. It loses track of the number of bytes it's pulling off, and that causes the card to reset.
That card also works with the unit that will make sure Phoenix has the correct attitude during landing. A reset could mean that the craft lands on its head, not its feet. After landing safely, the $420 million Phoenix mission will be headquartered from the Science Operations Center at the University of Arizona, the first time NASA has allowed such off-site control. Here in July, the scientists themselves undergo testing.
Let's start with the most important activity we had yesterday, which was the robotic arm unstow. Matt, are you...
There were no faults detected.
Okay. And did you get an SSI image of its final position?
SSI image.
Okay.
We are conducting our first operational readiness test, which is our first full-up full-scale test of what we're going to do when we get to Mars.
So there is a set of criteria in your email, Peter?
And working as if